Hello, hello, hello. Welcome back, guys. It is Monday, the 20th of July, and today we're going to be doing some strength training for the ESAT, specifically for the physics side, because we've gone through now the full spec. We've done an additional deep dive into the spec, going through the calculus stuff and the detailed notes that they have available. I've also been through some of the speed training for how to get that muscle up and running. But in terms of papers to use at this early stage, before you start burning through the NSAA past papers, I wanted to show you how to make good use of the old style section 2s that I mentioned in my ESAT Everything You Need to Know video. So I'm just going to run through an old style section 2, a new style section 2, and a PAT test to kind of show you how those can be used in your prep. So one thing I would say about those papers is, like, I kind of use, like, in my sort of work with students, I always use this sort of terminology, front end, back end, where front end is about, like, in the high jump metaphor, it's like how high a bar can you clear, whereas the back end is what height can you clear every single time. ESAT in general is about the back end. So it's about syllabus mastery, knowing you're going to get it 100% of the time, no sweat, can do it without thinking, do it at a running pace. Whereas front end is much more interview stuff. It's more sit down, work out, can I get over the line on this, rather than trying to do it to time. So as I'm doing these papers, I won't be doing them speed run. I won't be doing them to time. It's more to show what physics is included in them, how they kind of push you, and as well, these are looking ahead past the ESAT in October towards a potential interview, right? Because you got to be bearing that in mind as well. All of this stuff, like, works in symbiosis, right? Getting really good for the ESAT will make you good at the interview. Getting good at the interview will make you good at the ESAT. So all of this sort of in together. This is helpful for the interview, where you kind of sit down and just try and solve a problem where it's not about the speed work, it's just about getting it done. So without further ado, which I do feel like I say every single time, I'm going to put you guys over here. I'm going to get the papers up. I think I'm going to do them. So the order I gave you on the Everything You Need to Know for the ESAT thing was PAT tests, then old style section 2s, then new style section 2s. So I think I'll do them actually kind of in reverse order, because the new style section 2s are very much in the style of an ESAT with the multiple choice and use similar skills. So I think I'm going to put that up front because it's the most useful. So sharing screen, window, that window, let's go. Yeah, you can see it well. So I'm going to show you specifically how you can use it for the physics, but you can also use it for the chemistry. Now, I want to tell you off the bat, these are harder than the ESAT questions you are going to see. They can sometimes rely on material that is not in the specification because it's a little bit more advanced, but I think it's still useful to do to kind of push your front end limit. So getting into it with the physics. Yeah, again, these are just, you can totally see an adaptation of this for interview, where we have, if we draw this out, we've got one spring, two spring, with a force stretching them both. So here F is equal to 1x, and here F is equal to 3. Well, I'm not going to call it x because it's a different extension. So what we know is that because the force is the same through there, we know that x is equal to 3y, and we're told that x plus 3y is equal to 6, which means that 6y is equal to 6 when you sub that in there, and y is equal to 1, and x is equal to 3. Sorry, that's not true at all. What am I saying? It's x plus y, because y is the extension there. So let me try that again. And that's the thing. It's okay to make a mistake as long as you catch it. Because again, this is front end. This is kind of interview stuff. Hello, Vivan. How's it going? So we know the sum of the two extensions is 6. We plug that into here. So it actually means that 4y is equal to 6, which means that y is equal to 1.5. X is equal to 4.5. Yes, they add up. So the extension in P, which was this guy, is X is 4.5. This one I use with students all the time to talk about how to do non-calculator simplification. So here, we've got this radius, we have a length, we have a resistivity, we have 12 strands in parallel, and we want the resistance. So R is equal to rho L over A. So we have rho L. Now the area, the combined area will be 12 times pi times R squared. Ooh, common question. In the last stream, you mentioned that you should be prepared with your chemistry knowledge for a physical NSAA interview. Correct. For Cambridge, not Oxford. Does the same apply for engineering science? No, because engineering science, they're really just asking you about the math and the physics, whereas with NSAA for Cambridge, it is expected that you would also be doing chemistry as well, which is why it's relevant to come up in interview. It wouldn't be as relevant for engineering, and I wouldn't expect it there. You're all good. So getting back into it. So here, 4.8 times 10 to the minus 7 times 15. So that's 12 times pi. Now, I could really have done this in one step, but that's 4 times 10 to the minus 8. Now, let's look at some of the ways we can simplify this, right? So first of all, we can call that, we can alter the powers of 10 here and call that 48 times 10 to the minus 8, so that these powers of 10 cancel. And then look, we've got a 48 and a 12 and a 4, which also cancel. So while these numbers looked really ugly at the start, they know it's non-calculator, and so that's their kind of hint to you that things should cancel down, and this reduces immediately to 15 over pi. Super, super helpful technique. So never actually doing the math, kind of just like knowing that it's going to simplify and trusting that process. Now here, this does feel rather ESAT still. So we have a semicircular transparent block, and we have the length xy as being L, which means that this radius from x to the middle will be L over 2, which is the same as P to the middle, and the middle to Q will also be L over 2, so the path from P to Q is still L. So time taken is distance over speed. So the distance will still be L. And now we have to work out the speed of light inside the block. So we know that N is equal to C over V, where C is the speed of light in a vacuum and V is the speed in the block. Ooh, apologies. So if we work out N, we also know that N is equal to 1 over sine of the critical angle. And we're told that it's at the critical angle, which is 60. So it's 1 over sine 60. And I vow to you, I will never know what that is. I always use my triangle. Sine 60 is root 3 over 2. 1 over that is 2 over root 3. And so here, if we want it to be d over v, so it's L over v, we need to work out what v is. So here, if c over v is equal to that, let's divide both sides by c and multiply both sides by L. 2L over root 3c. That is available here as option C. Now, you could, let's talk about like the little techniques in this. So it might be really tempting to rearrange this for v in terms of c and then substitute that in. But if I'm seeing a 1 over v here and a 1 over v here, it makes sense to do it the way I did it, because like it kind of just simplifies the steps, right? It displaces things as little as possible and makes it much less likely that I'm going to make an execution error. So maybe in your slow practice, finding little techniques like that to kind of find your smoothest, most efficient solution path. Here we have a solid cube with side lengths of and we're talking meters. So it's physics, so I'm always looking at these units. So it's 0.2 meters, and we're cubing that. So it's going to be 0.12 and then 8 meters cubed. That's the density. So the mass is density times volume. So it's 2 times 10 to the 3 times 8 times 10 to the minus 3. Those will cancel, so that it should be 16 kilograms. Strain energy. I think this is on... Is this on your spec? Regardless, it's not too bad. So the elastic strain energy is a half kx squared. So 3.2 is equal to a half times the k that we're looking for times an extension. Initially unstretched spring results in that. Okay, so what we know is also that the F, so we also know that times, okay, let's do this. I think this is going to be simultaneous equations. So a half kx squared is equal to 3.2, and 160, F equals kx. Yeah, the stress strain stuff, as in physics, you don't think it's on the ESAT. It's not stress strain stuff, actually. It's just Hooke's law stuff. So F equals kx and E equals a half kx squared. I know F equals kx is in there off the top of my head. Not quite sure about this elastic strain formula. Sorry, you're right. I didn't mean to say elastic strain. The strain energy formula. But interestingly, similarly to what I was saying just on that last question about like techniques to quickly do the math, you've got a bunch of options for this, right? If you see something like this, so I'll show you two ways of doing this. Either, because we want to solve for the spring constant, which means we don't want x. So either we say x is equal to 160 over k and sub that in here. Either way, I'm multiplying both sides by 2, right? So 6.4 is equal to kx squared. I could plug that into here. So k is equal to 160 squared all over 6.4. So how am I going to do that? Nice and simply, right? First of all, I'll multiply this out because I'm going to then multiply top and bottom by 10. And I'm going to take an 8 from there and turn that into 20. I'm going to take an 8 from there and turn that into 200. So it just becomes 2 times 200, which is 400. So finding these little techniques to get around the math so you're not actually sitting down and evaluating this, that is so crucial for a lot of the ESAT work that you're going to have to do. So K is 400. There was another solution path, though, which is to say if 6.4 is equal to kx squared, and 160 is equal to kx, we could instead have squared both sides of this and then divided. So if we divide bottom by top, that's another way of getting to 160 squared over 6.4 is equal to k. So it's just a matter of working out which solution path works for you and how your mind works. So here, getting really good at solving your projectiles and your SUVATs under time pressure. Projectile is fired upwards 60 degrees to the vertical. So it's done like this. Now, again, this is a classic. Oh, look, it's my 30, 60, 90, guys. So if that's 20, that's 10 root 3, and that's 10. And I don't need to bother resolving them in any more complicated way than that. So I've immediately just found the vertical and horizontal because I understand my triangle and how it scales up. So now in the vertical, our SUVAT looks like h above the starting project. So it's that. Vertical is 10 upwards. Acceleration is minus 10 because it's downwards. Downwards vertical component of velocity is 4. So that's that one. Now horizontally, we just have distance, speed, and time. So the horizontal distance is d. The initial one there is 10 root 3. And the time, again, we don't know. But we do know that that time is the same. So we have to work out d and h. So from here, we can, so v equals u plus a t. So it takes 1.4 seconds. So we can work out d quickly. So d is equal to 10 root 3, distance equals speed times time. So it's 14 root 3. So that's immediately these guys. And then from the vertical suvat, we know that v squared equals u squared plus 2as. So 20h is equal to 84. 10h is equal to 42, and h is equal to 4.2. So the answer must be G. Not too bad. I love this question. Sorry, I've very much done these before. I should have mentioned that. I love this question because people really don't understand amplitude on longitudinal waves. So what we see here is that this is where it started, how it started, how it's going. So we can see that the 4 has not changed its displacement. We can see 0 has not changed its displacement. 8 has not changed its displacement. And between here and here, they're displaced to the right. And here, they're displaced to the left. So what we kind of expect is the displacement should look like this, where if we consider right to be positive, we've got this kind of situation. So that's the 0, that's the 4, that's the 8. We would expect the amplitude, this maximum displacement, to exist halfway between the 0 and the 4, so at the 2. So let's look at what's happened to the 2. So it was there, and it's traveled to there, where each of these blocks is 0.2 meters. So the amplitude must be 0.7 meters. So you look at the maximum displacement for equilibrium for any particle. And similarly here, the 6 is displaced 0.7 to the left. Okay, let's look at this. Looks like, again, it's going to be some sort of simplification problem. So we have this mass traveling at this speed and this kinetic energy. So we can immediately say that 1 times 10 to the 12 is a half m v squared. So that turns that into 10 to the 8. I'm going to turn that into 100 times 10 to the 6 equals 4v squared, because then that becomes 25 times 10 to the 6 is v squared. So you see how I, again, manipulated that to make 100 divided by 4 come to something very easy, right? It really helps. So that's the initial speed squared. So the initial speed is 5 times 10 to the 3. So we have an external impulse lasting for 2 seconds. So impulse is change in momentum. So it doesn't really, that doesn't affect it. The impulse, so the change in momentum is 8 times 10 to the 7. So 8 times 10 to the 4 times delta V is 8 times 10 to the 7. That obviously cancels, that cancels. So the delta V is equal to 1,000. Acting in the opposite direction to the motion. So it slows down to 4,000 meters per second. And now it's asking for the average rate of loss of kinetic energy during the application of the impulse. Well, that is going to be, so a half m into v squared minus u squared. That is the change in kinetic energy, which is negative, all over a time of 2. So I'm seeing that immediately cancels. So it's, and the difference here is 9. So it's a change in, so it's 2 times 10 to the 4 going into, now this guy, so it's minus 9 times 10 to the 6. So it's minus 18 times 10 to the 10, so minus 1.8 times 10 to the 11, which is B. So again, piecing together all the information and simplifying it as best you can. Solid triangular prism. Sides of the triangular cross section are length that, height is that, density that. What is the minimum pressure it can exert? Well, that's when the force is on one of these. So the minimum pressure is equal to the weight over 3x squared. I'm just going to tell myself that. So now we need to get the weight. Weight, we're going to do volume times density is mass. So mass is density times volume. The volume is the cross-sectional area times 3x, where that's an equilateral triangle. So that's going to be 60. And that splits again into your 30, 60, 90, where that's x over 2. That's root 3x over 2. So the area there is root 3 over 2 x times the base, which is x, times the height, which is 3x. And that's your volume, and we're multiplying this by rho. So it's 3 root 3 over 2 rho x cubed is the mass. We're going to multiply that by g to get the weight, and we're going to plug that in here. G all over 3x squared cancels that down to make that an x. Those 3's cancel, so the pressure is root 3 over 2 rho gx, which is not an option. Where's the 4 coming from? Because that base is x, the height is root 3 over 2x. What have I done wrong? Hold on a minute. Okay, let's do area of any triangle. So a half AB sine C. So a half x squared sine 60. Oh, of course, it's half base times height, because I'm an absolute moron. Oh my god, I got the area of a triangle wrong, guys. Yay, go me. Get into Cambridge with me. Okay. So yeah, so it's a half of that. So it's a half base times height. So that should have been 4 the whole time. That becomes 4. So it's root 3 over 4 rho gx, which is f. Okay, here. Apologies, throat's a little dry this morning. So we have an apple of mass, MA, placed on a uniform meter rule. Center of gravity at the 10 centimeter mark. So that's where the apple is. So that's the mass A times G. The pivot is placed at the 35 meter mark. So that's 0.25 there. And we know the mass of the ruler, and that's 15 centimeters from there because it's a uniform meter rule. So it happens at the halfway point. And we also have one where the new pivot is based at this 40 centimeter mark. So that's 0.1. And the apple is replaced with an orange. So the orange is at the same place, which is at the 10 centimeter mark, which means that's 0.3. So what we know is that from moments, 0.25 mag equals 0.15 big mg. So that becomes 5 over 3 ma equals the mass of the ruler, from simplifying that down. And then from this one, we know that 0.3 mog equals 0.1 mg. So 3 mo equals the big mass. So we want to set those equal to each other. So 5/3 ma is 3mo, and MA over MO, therefore, is equal to 9 over 5. So you can see how these really feel very ESAT, which is why these are kind of the best training to do as you get closer to the real thing, to kind of get into the style of that ESAT, while still coming out above it so that the real thing feels easier. So a cyclist travels constant speed of 12 on a level ground. The power needed to maintain a constant speed is that. Well, power is force times velocity. So we can work out the force of resistance that he's overcoming. So 900 is 12 times that force. Divide both sides by 3 first, and then the force is 75 newtons. We have a total weight. Now it cycles up a slope at the same constant speed. It's at an angle of 30. What is the driving force as it travels up the slope? Assume the magnitude of the resistant forces is constant. So we've got that 75 down. We've got 850 there. That's 30. So the component of that down the slope would be 850 sine 30. And I promise you, I will never once learn them. So sine 30 is a half. So 425 plus 75 is, so there's 500 newtons acting down the slope. That's the resistive force you have to overcome. And so the power you have to generate is that 500 times the speed of 12. Now factor redistribution, I'll take a 2 from there, put it in there. So that's 1,000 times 6, which is not an answer. What did I do? Okay, so I agree with the 75 newtons resistive force. Do I agree with this? 30 degrees to the horizontal. Sine 30, that is the force acting down the slope, certainly. And sine 30 is a half. And half of that is 425. Oh, hang on a minute. Oh, I overshot the mark. What's the driving force? So the driving force has to equal the forces acting down the slope, so it is just 500. Okay. So that, making sure you're, like, again, in the style of an ESAT with the multiple choice, making sure you've really read the question and really understood what you have to do to get over the line. I love this question so much. So much. Because a lot of people can't come up with the 4 different arrangements there are for getting 3 identical resistors together. So here's what I see most often. People obviously know this one. People obviously know this one. The one in the middle I see most often is 1 in series with the 2 in parallel. The one people forget is you can have 1 parallel branch with 2 on it and 1 with 1 on it. And that's another way of getting 3 sort of combined. So if these are all R, this becomes 3R. That bit there becomes R over 2 plus R gives me 3 over 2R. Here we have 1 over 2R plus 1 over R is equal to 3 over 2R. And if I flip that around, I get 2R over 3, which is the resistance here. And this becomes R over 3. What we then know is that 2 of them are in this ratio of 18 to 8, which is in 9 to 4. And that's these 2 are in this ratio. So those 2 are in the ratio of 9 to 4. So this one has to be the 18 and this one has to be the 8. And that means that R is equal to 12, which makes this guy 36 and this guy 4. So the other 2 are 36 and 4, which makes it D. So you can find some really good challenging questions in here. We got another electricity one. So we have a fixed resistor in series with an LDR. So we got 100 volts. We got a 4 kilo ohms fixed resistor. We have an LDR. Okay. So the current is this, which means the current in here is also known, which means the total resistance is known. So the current through the battery, so 100 times 5 over 1,000 is going to be 0.5. Nope. Because that V equals IR. What am I doing? I should, so VR is equal to V over that. So it's 20 kilo ohms. So that is currently at 16 kilo ohms. The intensity of light now decreases and the voltage across the fixed resistor changes by 50%. So voltage distributes in proportion to resistance. It's currently in a 1-to-4 ratio. So this should split in a 1-to-4 ratio, so it should be 20 volts and 80 volts. If the light intensity falls on the LDR, its resistance goes up, which means its share goes up, which means the share of this goes down. So it should fall to 10 volts and 90 volts. What is the change in the resistance of the LDR? Well, that is now a 1-to-9 ratio. So this resistance must be 9 times that. So it goes up to 36 kilo ohms. And so that's a 20 kilo ohm change. Here we have an elastic cord, spring constant K, connected to 2 fixed points. And we have a diameter, taut but unstretched. The midpoint is pulled and fixed to a point on the ring halfway between. So people think that this line is it being pulled. It's not. It means it does something like this. It's pulled down to be stretched like that. Where if that's R, that's R, that's R, that's root 2R, that's root 2R. So the energy stored is a half kx squared, where the x is the extension. So x is equal to these guys, so 2 root 2r minus the original 2r. So I'll take out a 2r into that, and it becomes root 2 minus 1. So here it's a half k into that thing squared. So 4r squared, and then I have to square this, so I get square the first, square the last, and twice the middle two. So it's 2kr squared into 3 minus 2 root 2, which is f. This is what I haven't done in a very long time. So this is going to be the closest you're going to get to a live solve, I think, on this. So an object of mass m experiences a resultant force of magnitude f. The force acts in a single horizontal direction with a magnitude that varies with t, according to this. Initially at rest, where those are constants, it's at rest. Momentum. So momentum, so impulse, force is rate of change of momentum. So if we integrate force with respect to time, we get impulse. This is definitely not on your spec. But it could be a good interview question, this actually. So that's because it sort of reinforces the integration we saw last time. So if we integrate that with respect to time, we get xt plus 2/3 yt to the 3 over 2 plus c, but we also know it's at rest. But this is momentum. It's at rest, so the initial momentum is 0, so c is equal to 0, so the momentum at time t equals c. That is the momentum at time t equals t. So it's equal to t into x and 2/3 yt to the half, which I think is A. It's interesting. I'm going to have fun checking that one. Do not worry about that. That is beyond the level of the ESAT, which is again why I say this is sort of front end, pushing out sort of past the ESAT towards the interview so that you can settle onto the ESAT well. Displacement is given by that. How much work done? Huh. Again, this is beyond ESAT now. So we've gone into the difficult section of the section 2s. This is to really give your brain that nice push. And this is why we're not doing it to time, so that you can really focus on the actual content. So displacement is given by that. I know that work done equals force times distance moved in the direction of the force. So that is an individual work element. So the work done would be the integral of f dx. Now, that f is ma. I think. Yeah. So we can differentiate this with respect to time and get that v is equal to 4 plus 4t, and the acceleration is just 4. Oh, so it is just a constant force. Okay, that's not too bad, guys. Because if it's a constant force, all of this is utterly redundant, which is great. So work done equals force times distance. When t equals 5, when t equals 0, x is equal to 8. So it starts off at 8. When t equals 5, x is equal to 8 plus 20 plus 50. So in other words, the distance it's traveled in that time has been this 70. So work done equals force times distance, which is equal to 840. So I'm going to go with E. I immediately know I'm not going to like this. Because I remember this question. I've seen it before. So we have a light ray passing between these mediums. So you can see why I use these as sort of interview fodder. So the boundaries are parallel. The ratio of the speed of light in the medium p to the speed of light in medium q is 2 to root 5. Now, the reason why that matters is refractive index, because n equals c over v. So v equals c over n. So that kind of thing. And now we've got so if that's theta. You had an exam today. How are you having an exam in July? Oh, are you in India? Because I know Indian schools are already back in session. So here we know that nq sine theta equals nr sine 45 from this boundary. But here we have np sine, oh, sorry, theta was taken. Call that alpha. Hello, hello. You say you're the person in my Discord. There are many people in my Discord. So NP sine theta equals NQ sine alpha. So it's equal to NR sine 45. Yeah, refractive index and all the other stuff. So what we know, therefore, is that sine theta is equal to sine 45, which is 1 over root 2 into NR over NP. So we have to work out what that thing is. So the speed of light in P to Q to R, that's 2 to root 5. That's 3 to root 6. Let's multiply these up so the Q's are the same. So this needs to be multiplied by 3. And this needs to be multiplied by root 5. So the speed in P compared to the speed in R is 6 to root 30. So if I but here, these are inversely proportional. Wait, I'll come back to this I'll come back to the chat once I finish the problem. I hate this for some, I don't know why, my brain hates stuff like this. So what we know is that why are you not drawing? Okay. What we know is that if we divide by this, VP is 6 over root 30 times VR. We know this to be true, which means that C over NP is equal to 6 over root 30 times C over NR. These guys cancel. We want NR over NP. So that means that NR over NP is 6 over root 30. And that can go into here, which is 6. That becomes over root 60 then. So it's 6 root 60 over 60. That cancels down to root 60 over 10. But there's a 4 in that can come out the front. So it becomes root 15 over 5, which is E. Ugh, hate it, hate it. Right, back to the chat. Oh, when to sit the ESAT. Yeah, there was a guy in my Discord asking when to sit the ESAT. Yeah, I remember this chat. What level do you need to be working in A levels to be eligible for the ESAT so you can find it medium in difficulty? You need to, well, first of all, it's not so much about where you need to be in your A level. Go through the spec. The spec is everything. If you understand the spec to a high degree of mastery, then you're good to go, including the detailed notes that come along with them if there are any new concepts. In terms of the UK system, that would be mastering AS level math and physics. Which sitting do you advise for Imperial, since you can do either? You're confused on what to choose. My advice in the Discord server is the same as it is now. It really depends on you, your preference, and your readiness. You want to put in the best ESAT you can. If you think that using that extra time to get good and ready is going to make you sit the best paper possible, sit it in January. If you know you're ready now and that delaying it would just sort of not really add much and would kind of get in the way of your studies, then do it now in the October sitting. So it's a matter of how prepared you feel. You can go through some past papers, see what your scores are. Because I know if you delay it to January, it can really ruin your Christmas holiday sometimes, to sort of have an exam right as soon as you come back. So yeah, in general, the safest option would be January because it gives you more time to prepare. It makes you feel the most ready. But if you might be someone who's like good and ready to now, in which case I would definitely advise getting it done earlier. So it's, yeah, I don't have enough information to make that decision for you, but that's how to make the decision. Oh, the biology section of the ESAT. The bio, I haven't done bio since GCSE, so I would be useless there, but I could do some chem if you need any chem. How many A levels is recommended for Imperial? 3 or 4. Like it doesn't really, you don't need any more than 3. It depends on what you're going for. Like the course requirements will be given to you for the individual course. The only debate is whether you can get in without further math. Theoretically speaking, you don't need the further math, but it's certainly helpful. So especially if you're talking about Imperial for engineering, then something like a math further math physics is a really good option. If you're getting in for other things, obviously it depends on the specific course requirements. But you can get in without further math. Yeah. I would say, in which case, if you don't have further math, that's all the more reason why you should smash Math 2 in the ESAT so that they don't have any doubts about your math ability. You're doing Math Phys Chem. If you're applying for engineering, yeah, so you would have to do Math 1, Math 2 physics, smash the Math 2, smash both maths, and then they'll be like, okay, this person's math is not an issue. So smashing Math 2 depends on your ability to really master the A-level math syllabus that you've been taught so far. Okay, so getting back into it. But actually, that's a good point. So coming back to so I can't do biology. You've heard bad things about the ESAT from others. Yeah, because it's a terrible paper. It's awful. It's great. It's brutal. It's so fast. And so getting up to that speed is really difficult for people, but everyone finds it bad. So everyone's in the same boat. I will say the further math actually does not help you in any way with Math 2. So the further math is actually kind of redundant when it comes to your ESAT. So you don't really need to worry about it from that perspective, but you do need to make sure you've really mastered that math from GCSE and AS. And weirdly enough, I find people doing further math struggle more with Math 1 than Math 2. I don't know why the Math 1 comes out so difficult. Yeah, chem. So I think, yeah, I've got some time. So why don't I'll throw some chem in the mix, I think, sort of from next week. Because once I've done this, then I've kind of talked about everything I want to talk about with the physics in terms of the spec, in terms of like how to prepare. So throwing in some chem in now that I've got some time is not a bad idea. Yeah, further math people struggle with the single. Yeah, so I think it's just a case of just being prepared for the math that you are going to see. So if you're doing Math 2, you know that's going to be based on AS level math. Get really, really good at the AS level math, and then don't worry about the redundant further math that everyone else is getting. So it's just the classic case of know what you have to prepare and prepare that and only that to the highest possible standard. Right, let me get back into this because we got a couple questions left on here. Oh, actually, no, we got some more chat. Do I do tutoring as a profession? Nope, tutoring is full-time gig for me. Oh, ESAT bookings are live today. Guys, get on that. I did not know that. That is so, okay, if you're doing the October sitting, because especially if you're based in the UK, especially if you're based in London, those go instantly. I remember last year, it was like booking Eras Tour tickets. Like people were getting like thrown out. The servers were all busted. People having to go out to Basildon. So get on that. Stop watching me. Go book your ESAT. Will they run out? They will not run out, but all the desirable places will run out. And it may involve you having to like drive an hour out of your way to get an 8 a.m. slot in Basildon. So get on that. Oh, good. 3 p.m. UK time today? You're fine. That is good to know. Do I have anyone doing the ESAT? Because now I'm panicking. Like, do I have anyone? No, I don't think I do. I think I've got some TMUAs this year. Oh no, I do have one. I do have one. So I will message her right after this. Thank you for letting me know. Although she's in California, so she's gonna miss it. But yeah, Midlands, you're gonna be fine. Right. This is your friendly announcement to everyone else. It's ESAT booking day. That should be your number one priority. I guarantee the servers will crash. Don't worry. Just try and get through and book a decent slot. Okay, so we've got this question. This I like. This one I like a lot. These horizontal ones are quite easy, where the river's flowing at that, and the swimmer has a constant speed of 1 relative to the water. So here, we know that time is equal to distance over speed. So here, the actual speed would be 1.5. So that would be 30 over 1.5, which is 20 seconds. Here, so they're traveling 1 to the left, and the river's pushing 0.5 to the right. So the net is 0.5. So down here, time is 30 over 0.5, so that's 60 seconds. Now it's the sides that are tricky, and I want you to pay attention. So this is the resultant velocity. They end up traveling straight upwards. So the resultant is this. Now that is the vector sum of the actual velocities, one of which is this. But one of which is, sorry, you have to start there. So one of which is that, the other of which has to be this. So that has to be what so the water is going 0.5. The swimmer has, which we know is doing 1, has to be going like that to make the resultant this vertical one. And so this is just a scaled up 1, 2, root 3. So this becomes root 3 over 2, becomes that resultant speed in the vertical direction. So that time is 30 times 2 over root 3. So that becomes root 3. That cancels down, makes that 10. So it becomes 20 root 3 on both of those legs. So in other words, the total is 80 plus 40 root 3, which is D. Stress is decidedly not on your spec. If you have covered that and you want to prep that for interview, this is a good question for you. So stress does that, and is then maintained at a constant value, and it does not reach the limit of proportionality. The table shows properties of steel used in the cable and the dimensions of the cable. How much work is done to stretch the cable? Well, that means the strain reaches a constant value, so it stops extending. So Young's modulus equals stress over strain. So the strain is 4 times 10 to the minus 3, which is the extension over the original length. So the extension is 16 millimeters. Got it. What we also know is that the stress is equal to the force all over the area. So 16 times 10 to the 4 is equal to the force. Now work done is force times distance moved in the direction of the force. So it's 256 times 10, so C. So that's displacement time. Now you notice this is not asking for a velocity time graph, this is asking for a velocity displacement graph. So this is constant positive, then 0, then big or negative. And we know the displacement will end up being 0 because it travels back. So actually, it's none of these ones, which end on a displacement not being 0. We know it starts off small and they're constant, so the velocities do not vary. And then we know it starts off with a smaller velocity and ends on a bigger velocity, so I think it's c. And then finally 20. Oh, Jesus H. Christ. No. I hate it. I hate it. Okay, guys, this is brutal. This is peak interview prep. So if you are using these paper twos in your preparation, the section twos, the earlier questions are very good ESAT prep. The later questions are very much getting into interview territory. So we have an EMF and an internal resistance and a variable resistor, and the resistor is adjusted, and we want the maximum power. I'm not going to use the maximum power theorem, which says that the maximum power is going to be when that external load resistance equals the internal resistance. We are going to say we have that's EMF E connected to R equaling Ki squared in connection with a variable resistor of resistance. I will call that R. So we know that V equals I into R plus little r. So it's IR plus KI cubed. Okay. So from that, I know that's when we can solve for the external resistance equaling E minus KI cubed all over I. Okay. In other words, E over I minus KI squared. Cool. I'm gonna park that. Now we need the power in this. So the power is equal to I squared R. So it's that times I squared. Oh, I will get to that question. So it's going to be I into E minus KI cubed. So it's EI minus KI cubed. KI to the 4. I wonder if I want, so dP di is equal to E minus 4KI cubed, which will equal 0 at maximum power. So I know that I cubed will equal E over 4K. And I know that the resistance will therefore be one over I, which will be 4K over E to the 3rd into E minus KI cubed is E over 4, because you just multiply this by K. So that becomes 3/4 E into 4K over E to the 3rd. And I can bring that in by cubing all of that. So that becomes 27 E cubed times 4K all over 4 cubed E. That all to the 3rd. Now that will cancel down to make that 16. So it's 27 E squared K all over 16 to the 3rd. And I think you can take that 3 out. So it's equal to 3 into KE squared over 16 to the 3rd. which is D. Brutal, hate it, monster. Right. How to make a decision under time pressure. Okay, so you got a few seconds on the clock. What I would do is see if there is some part of the question you can do quickly. So eliminating a multiple choice sort of round of options, right? So if you so for instance, in fact, this was a very good. This question 19 was a very good example of how to make a decision under time pressure. So you look at 19. You look at the displacement. It comes back and it ends with a displacement of 0. So look what I did. I immediately got rid of half the options with just that one instant realization. And the realization that velocity is constant gets rid of these other two. And then under time pressure, you're then coin flipping between 2 options instead of 8 options. So find a way to reduce your options that you're guessing between, because that will maximize your probability of guessing correctly. And from there, you guess. Let me make, I'm just going to mark these up and make sure I got them okay. That's good. Okay, so that was 2020. Let me just check from the answer key. I'll do this off camera, just like real quick, just to see, or rather, because the mark scheme's on a different application. So I'll put the mark scheme here and I'll start sharing my screen so you guys can kind of see what I'm doing. So here, let me go to the top and let's mark it up. So assuming I'm looking at the right mark scheme, we have E, then D, then C, then E. So I got that wrong. I was off by a power of 10. Of course I was off by a power of 10 because that was 20 times 200, which should have made that 4,000. Apologies. So that was... See, look at that. Execution error. Silly. So, okay, what can I take away from that? Maybe instead of execution errors mean I've probably laid something out on paper wrong. And what I should probably have done is just cleaned that up. And so therefore it's equal to 20 times 200, which is 4,000. So that every execution error informs your strategy somehow. You can make your changes. G is correct. D is correct. B is correct. F is correct. F, C, D, 12D, 13F, 14A, 15E. This is very much in the sort of interview territory now. E, 17. Can you imagine how bad the ESAT would be if stuff like this was still in it? Bad, 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 bad. 18. I got this wrong. Why did I get this wrong? Because it's half kx squared. See, I was off by power 2. But again, I'm not too mad at that. That felt conceptual. Like I just conceptually got that wrong. But that's... In an interview, they would be there to poke you and kind of get you to the right answer. And in the ESAT, this isn't coming up. So I'm actually not too mad about that. Yeah, I shouldn't have used, because it's not a constant force and it's not a constant distance moved. Well, it's mainly the constant force is not the same as the issue. So that was the wrong equation to use. I've just forgotten the formula for that and tried to wing it. And 20 is D. So that's kind of how to use their section 2s. Oh no, I don't want to do that. No. Okay. Right, so in the interest of time, how am I doing? Let's talk about what the old style section 2s were for NSAA. I may not have time. Let me check my calendar. Am I going to have time? I may not have time to do a PAT test. I may have to do that in another stream. But it's fine because let me show you. Okay, so the next best thing, these old style NSAA section 2s, the ESAT section 2, sorry, the ENGA section 2s can also be used here. These were long form written. These are good ones to burn through. Again, this is pushing your front end physics ability to make sure you can handle the ESAT when you come back down onto it. And this is also good interview prep. So let's see how I tackle this. So we have a narrow beam of molecules with a range of different speeds passing through a molecular velocity selector. We have two disks rotating in the same direction at the same frequency, but offset a little. So it means there's some time that passes when you get through this gap, and then this will rotate. And if the particles take the exact right amount of time to get between the two, it will encounter the gap there as well to get through. So here, if it's 160 revolutions per second, that means it's 160 times 360 degrees per second. So that's how many degrees in 1 second. So we want 1 degree, so that's going to be 1 over whatever 160 times 360 is. And this would have been, yeah, calculators may be used in this section, so this is very old. But whatever that is, that's the answer. So if theta is equal to 30, d equals 24 centimeters, and that's F, what's the highest speed of a molecule that will pass through both slits? So the reason why it's highest speed is because it's going to get there as fast as possible. So the only way you're going to get, if you're too fast, you're just going to smack straight into the next disk. So the fastest one that still gets through is one that, like I say, sort of perfectly aligns such that this time is the time taken to travel 30 degrees. So the time taken there is d over v. So when that time equals the time taken to travel 30 degrees, well, this is the time taken to travel 1 degree. So it's when d, which is 0.24 meters over v, is equal to that guy times 30. 160 times 360, cancels, 112, whatever that guy is. And that's, so then the v is equal to 0.24 times 12 times 160. I wonder if I could do this non-calc. I can immediately see a power of 10 things. So I'll call that 2.4 times 12 times 16. I'm going to call that 1.2 times 12 times 32. So that then becomes 14.4 times 32. And then I'm kind of stuck there. So I can't do this non-calc, at least not easily. So I'm not gonna. But that would be the highest speed. When the speeds are measured after they pass through, it's found that other molecular speeds are present. Why is there more than one speed? Because if you're going slower, it may be that this guy makes it around a whole extra revolution, and then the gap is there again to go through. So we assumed that was for 30, but you can also get it for 390 degrees, for instance. Is there any better day to book my ESAT for? No. The 2 days, while they have different questions, are completely identical. Like, there's absolutely no way of predicting whether one day would be better than the other in terms of question. I would do it based on availability, right? If you know you're not a morning person and one day only has slots at 8 a.m. and the other has slots at 2 p.m., go for that regardless, right? There's genuinely no benefit of one day over another. Okay. Yeah. So here, calculate the molecular speed closest to your value that will pass through both slits. Well, that would be when, again, so V here is equal to, the next closest V would be the 0.24 times the 160 times the 360, but this time divided not by 30, but by 390. And whatever that speed is, would be the next highest speed that gets through. So each slit has an angular width of 0.3 degrees either side. referred to in part 2. So part 2, we're talking about the maximum speed ones. Yeah. So we're asking now for the range of speeds that would get through on that. Okay, so we know that the speed is equal to 0.24 times 160 times 360 divided by the angle you have to get through, right? So the bigger the angle you can get through, the smaller the speed. So that theta is 30 degrees. You have an extra 0.3 on either side. So you have an extra 0.6 to play with. So min would be that over 30.6. And V max would be this guy all over 24.4. And then by subtracting those, you would get the range of speeds that would get through. So now we've got one where it's particles falling through a hole. And they'll only get through when the hole is in exactly the right position. So the disk is rotating at f revolutions per second when the particle is released from rest. Working in degrees, write down an expression for the angle theta through which the disk will have turned by the time the particle reaches it. So it's f revolutions per second. And every revolution is 360 degrees. So it's 360 f degrees per second. Now, we can suvat. Oh, I shouldn't have written that there. We can do suvat here. Is it released from rest? Released from rest, good. So we can work out this time. So S equals UT plus a half A T squared. So T equals root of H over 4.905. I think that's 4.905. Yeah. So that's your time. So if it's that many degrees per second, we have to multiply by the time to work out the number of degrees. So that would be 360 f root h over 4.905 would be the angle you move through. Okay. So if f equals 20 and the particle initially at rest is released at the moment that the hole is vertically below it, what is the minimum height from which the particle can be dropped so that it will pass through the hole? So minimum height means the shortest distance, shortest time, 1 revolution, 360 degrees. So what we know in this case would be that 360 f root h over 4.905 would equal the 360 degrees to go 1 revolution. That obviously cancels. We want the height. F is 20. So 400 h over 4.905 equals 1, because that's 1. We squared both sides. So h is equal to 4.905 all over 400, and that's in meters. An identical disk with a similar hole is fixed to the same axis but at a distance that between it, the two holes are aligned. The particle is released at that height. It's able to fall through both holes in succession. What's the minimum frequency of rotation? So that's when it gets through the first hole, and then it's going to be rotating exactly once and then getting through the second hole. Okay. So what we're going to have to do here is to work out. So we're going to do SUVAT for the first episode of going from rest. Sorry, that's going to be 9.81 to here. So v squared equals u squared plus 2as okay, so that would be 19.62, and then you multiply that by 0.1. So whatever that is the speed there. And then you can do exactly the same thing here, where that's the new u, where that s is 0.15, that a is still 9.81. We can work out the time it takes to do that. Where one of those times would be negative. So S equals U t plus a half a t squared. You solve that for positive time. That's the time it takes to fall, which has to be the time it takes for one revolution. And F is equal to 1 over t once you solve for that. So these are, you can see that there's a way in which these are not good, because in an interview, you won't have a calculator. They won't ask you this style of question. In an ESAT, you won't have a calculator. They won't ask you this style of question. But it's still worth going through the motions to see if you can come up with a favorable solution path. So calculate the readings shown on the voltmeters in these cases. And on the ammeters. Well, that voltage is just going to be 3, and these will be the same current everywhere. V equals IR, so divide by that, these would both be 3 amps. Nothing too bad. Here, this voltage across there is still 3, so that voltage there is 3. V equals IR, so that becomes 3 amps, which is then going to split 50-50, so that will be 1.5. Not too bad. A more realistic model has internal resistance of 0.1 on both of them. Calculate the new ones. Well, if these now have 0.1, what will happen then is the amended version, once we incorporate the internal resistances of 0.1, so that total here would now be 1.2. So I would be equal to 3 over 1.2. Multiply top and bottom by 5. Divide by 3. It's 2.5 ohms. By that, I obviously mean amps for both of those. And V here is going to be 1 over 1.2 times the 3. So that becomes 10 over 12, which is 5/6 of 3, which is 2.5 volts. Now here, these would both have 0.1, which means the total here would be 0.05 equivalent resistance. Oh, that gets more interesting then. Because I think do we have simultaneous? Yeah, this is going to be a bit more involved to work out. So we have to add a 0.1 ohm resistor on both of those. So that's the equivalent of 3 volts on a 0.5 resistor. So V equals epsilon minus IR. So it's 3 minus A1 times 0.05. I think do we need simultaneous equations here? In any closed loop, voltage gained equals voltage lost. So 3 equals yeah, it does seem to be simultaneous, doesn't it? What's the quick way of doing this? When you have 2 cells in parallel, isn't the voltage... The EMF is certainly the same, but the voltage may not be the same here because we're incorporating the lost volts. So the EMF is certainly 3. And it's certainly true that the voltage across there... Yeah, but the problem is it's going to be 3 minus A2... times 0.1, basically. Which we don't know. So V equals that. We also know that because we know that A1 is certainly going to be twice A2. Yeah, no worries. So A1 is twice A2. That we know because these are like completely identical. Oh, you see, this is where I get hungry and then my brain stops working. No, I could do this. I believe in myself. Okay, so A1. But that sort of falls off there. And we know that this 3 volts is going to be equal to 1 times A1 plus 0.1 A2. I think this is going to be it, guys, because A1 is twice A2. So that becomes 2.1 A2. So we can get that A2 is equal to 3 over 2.1, which is 1 over 0.7, which is 10 over 7. Which means that A2 is equal to 20 over 7, which means that... Oh, and also V we could have got it a lot easier. So V is going to be equal to 1 over the 1.05 times 3, I think. What's 100 over 105 times 3? Divide top and bottom by 5 is 20 over... just 21? Times 3, which is, again, 20 over 7 volts. Okay, so we got that. That sucked, and I did not like that. So the 1.5 volts... Okay. So they each store the same amount of energy. In which of the 4 arrangements do the cells take the longest time to transfer all their energy to heat? So that's about power. If they take the longest time to transfer all their energy to heat, that's the minimum power. Still, lost volts. That may be because maybe you haven't learned that. Have you done internal resistance? Since wasn't it negligible? Okay, let's talk about it. So it's negligible in part A. It's not negligible here in part B. I just went back and used the diagrams for part A because I was lazy and didn't want to redraw them. Yeah. So I already did part one. Part one was like honesty, trivial, which is why I just erased it and drew back over it. Part one, it was literally just 3, 3, 3, 3, 3, 3. It was done. Like it was fine. So apologies. That's not you not understanding. That's you just sort of missing context because you joined later and I didn't present it well. So don't worry. You're good. So here they're negligible. Here they're not. I was doing B on A. Yep. All good. So which one's going to have the longest time to transfer all the energy to heat? So you can immediately see, again, this is feeling, because it's such a slog, this feels so much more interview-like and a lot less ESAT-like. But can you imagine how much easier an ESAT question is going to be compared to this? So if you can do this, you're going to be fine for ESAT. So V equals I squared R. How? It's only a 2 marker though, so it doesn't seem like we need to do some massive involved calculation. P equals I squared R, so it's more dependent on current than anything else. So I think we want maximum. So in order to get the longest time, we want the minimum current. But these have the same current. Damn, I can already get to the point where my brain is just disconnecting. I'm just like, get to the end. Jesus. Oh, this is why I should always eat before streaming. Okay, so B I've done. This one, I'm gonna cry uncle on this one. So let me see if I really want to see what they say for this. So for B1, what they're saying is that's when it doesn't have the internal resistance. This will last longer, apparently, because the rate of energy is provided by each cell is VI. Okay, so the power here in the cell, but in the cells. Okay, so we're talking about the cells here. The power here is 4.5. Whereas B part 1, again, that would be 4.5 watts going through that cell. This one here, where that was 1.5 watts. 1.5 amps even. Now that does seem like it would be 4.5. Am I understanding what they're saying here? For the rate at which energy is provided by each cell. Yeah, this is the part where my brain is starting to disengage. So what I think I might do, hold on a minute. So I'm not Okay, well, let's demonstrate this as if this was a prep. So this isn't really working. What you would do is you would, realistically, if you were in the state I'm in right now, take your break. You would just take a break and then come back to it. Am I going to do that now? Because I'm starting to wonder about the utility of this style of paper. Mainly because again, it's not non-calculator, which doesn't make it feel like it's good for interview either. And also, although we can talk about that. Look at what my brain is doing. I'm getting stuck in the mud. Exam technique, realistically, I should just skip that and see if the rest of it's any good. Well, yeah, it's gone to a completely different setup, so maybe I'll be fine now. Ideal cell of that. In series with an internal resistance of that. Operate a fan consumes that much power, requires a potential difference of that. And identical parallel sections with each section containing n cells in series. Oh no, this is fun. I'm back in, guys. This is fun again. So what do we know? We know we got some nonsense happening, but it's connected to a fan, which is 2.4 volts and 0.96 watts. So that will get us the current that has to go through there. But it also tells us the voltage that has to end up across each of these parallel branches. We know that I is equal to power divided by voltage. So that's 96 over 240, divide 12, I believe. Let's say times 12, yeah. Divide 4. Okay, 0.4 amps is the current. So now, in each of these parallel branches containing n cells in series, we know that the voltage, which has to be the 2.4 on that branch in, so it's got basically a bunch, it's got like cell, okay, how am I going to explain this? Because I actually do have to explain this. So what's going to be happening in one of these branches? We're going to have cell with a little resistor. We're going to have a cell with a little resistor. We're going to have a cell with a little resistor. We're doing that n times, right? So we have n of those. We know V equals epsilon minus IR in general, right? So we know for each of those, we know the voltage across it has to be 2.4. We know that epsilon is going to be equal to n lots of 0.5. We know the current is going to be, so that's minus, the current is going to be 0.4 divided by the number of branches, which is little n, times 0.10. And we know that there are 10 identical solar cells. So we know that n times n is equal to 10. So n over 10 equals 1 over n, which matters because that's in there. So 0.5 n minus. Now 1 over n times 0.4. So that's big N. 0.4 n over 10 times 0.10. So that's going to enable us to work out big N. Now, realistically, there's another way of doing this, which is it's only really going to be like 110 or 25, and you can kind of trial and error it, but this feels better. So I'm going to do that. So in other words, 2.4 is going to equal to n into 0.5 minus. That's 0.04, 0.004. Well, I don't like that at all. So that's 0.496. Does that divide? Have I done something wrong? That doesn't look like it divides. No. Okay, so what I should do instead is the alternative route. So let's say we had, Well, first of all, we know V has to be 2.4. So you're not going to get there on 1 and you're not going to get there on 2. So it's either going to be 5 or 10 in each thing, right? So that only gives us two possibilities. So it's either going to be 2 lots of 5 or 1 lot of just 10 across. Now, if it was 1 lot of 10 across, that would be 5 volts. Oh, we can also work out the resistance of this, I suppose. The resistance of this is 6 ohms. All right. So if there were 5 of them, that would be 2.5 and 0.1 volts are lost volts. Yeah, my brain is just slipping, guys. I've lost the plot here. But again, it's because this is feeling unsatisfying as well, because it just doesn't feel like how they would do it. So they've got rid of this. It feels like they've done it for a reason. Maybe it's just my brain being unfresh. But even that is instructive, right? Because what's happening with me right now, I know I'm doing this stream without having had breakfast. And you can see why they say breakfast is the most important meal of the day. So I got like an hour and a half in before my brain just like completely fell apart. So all of this actually matters, by the way, like the physical conditions, how much sleep you get the night before an exam, how much like food you've eaten, are you like primed and ready to go for your brain to do its absolute best. I also think I know in terms of me psychologically, the fact that I did the NSAA section 2, got that sense of achievement, then going into this is like, oh, I got to do another one. That might matter for you in terms of like maybe after the math 1 and then the math 2, you feel rested and then you don't feel as motivated to finish up with the physics. All of this is part of it, right? Like it's not just about knowing the physics, it's about getting the right stuff out of you. Yeah, I really should get breakfast. I am aware of that. I know I'm the problem here. This was ill-advised on my part. But yeah, I think either way, this has still been instructive. I'm gonna bail on this one. Maybe I'll come back to it and get sort of like sort of do myself justice here because circuits are fun. I know how to do circuits. But maybe yeah. So I think at the risk of just sort of watching me sort of flail in the mud and it's not actually instructive and useful, I'm going to call it there. But I think in terms of the overall, like I think it shows you again what these papers are like, and also look at the way I was reacting to that. I was like, that doesn't feel like ESAT. If it doesn't feel like it's actually being productive, you could tell with the later style section 2 with the multiple choice. I was like, oh, this feels good, and I was locked in and engaged. Whereas this, I'm like, well, it's just hard for hard's sake. Like it doesn't feel like it's advancing me towards my goal. So paying attention to that motivation as well and going, okay, maybe that's not the best, most relevant practice. Like, because that's the difficult thing. It's not like an A level where there's like a textbook and then all the past papers. There's like all these weird things. So people have been asking me like, do you get the ESAT Ninja? You can apply that same sort of thing that I've just been doing here. I'm like, well, that doesn't feel right. That doesn't feel ESAT, right? And that can sort of help you sort out what resources you want to use. I do think this shows you as well, like the utility of these different NSAA papers in your practice and preparation. How that new style section 2 is actually really good, whereas the old style section 2 can be good, but it's off base a little bit because it's calculator paper. And I think in the next stream, I'll show you how to use the PAT papers as well, because I think they can be a bit more relevant with the multiple choice, with the long form questions dealing a bit more sort of non-calculator. So I'll definitely show you guys that next week. I'll get some chemistry in the mix as well. But honestly, the fact that I've bailed on this, I think it shows you something about the paper, and it's like ability to prepare you for the exam in the way that you need to be prepared. So yeah, hopefully that gives you some more but also like still that think about that like that earlier 2020, the earlier section 2, the multiple choice section 2 we did, and how those earlier questions did kind of feel right on the money for pushing your ability to the next level, so that when you come back down onto an ESAT, it feels much more doable. You're kind of over prepared, and then you get into it, you're like, oh, this feels great, right? You feel very little resistance, and it gives you that good sense of confidence and momentum. So I'm going to end it there, because otherwise my brain's just going to explode, apparently, because I can't do anything. But I will see you guys next week. As always, feel free to drop in the comments or the Discord server if you have suggestions. So based on the suggestion today, I'll get some chemistry content in the mix. And I'll keep you posted, hopefully with a bit more notice for when I'm going to go live next time. But right, I'll see you guys. Have a very good week, and I'll see you next week. Take care, guys. Bye-bye.